Hi everybody. In this video we're going to talk about derivatives of inverse functions. So today in class we did a short exploration and we discovered a relationship between f prime of a and g prime of b when f and g are inverse functions. Okay. Now one of the key things to remember here is that inverse functions switch your input and your output. So if you, let's say, pick a value of x, and I'm just going to call it a, and you plug it in to f, you get a y value, or b. So f of a would equal b. Well, if f and g are inverse functions, then that means g of b would equal a, because inverse functions switch your input and your output. So then we discovered a relationship between these derivatives today, and we saw that g prime of b is equal to the reciprocal, or 1 over f prime of a. Okay, so because g is an inverse function, we would be finding the derivative of an inverse function. Okay, so the derivative of g would equal 1 over f prime of a. Okay, so this is one way to remember the rule, finding derivatives of inverse functions. But of course, we could take that rule and we can write it different ways. So just remember that if f and g are inverse functions, okay, here's another way we could write that same relationship. G prime of x would equal 1 over f prime of g of x, okay? And then because f prime of g of x is in the denominator, we know it cannot equal 0 because otherwise it would be undefined. Or we could use that dy over dx notation and say the derivative of y with respect to x is equal to 1 over the derivative of x with respect to y. Or instead of using f and g, we could also use our inverse notation, and so we get this rule where the inverse derivative of the inverse of f of x is equal to 1 over f prime of the inverse of f of x. So again, it's the same rule, just written different ways, okay? All right, let's look at a few examples. Okay, so we're going to start with a fairly easy one. Suppose that f is an invertible function. All that means is that you can find the inverse, which would be g, satisfying f of 3 equals 2 and f prime of 3 equals negative 4. If g of x equals the inverse of f of x, find g prime of 2. Okay, so start with your rule. G prime of b is going to equal 1 over f prime of a. Okay, now remember, like in this notation, this would be f of a equals b. F of 3 equals 2, so a is 3 and b is 2. So if we're finding g prime of 2, okay, then that would just equal 1 over f prime of 3. And notice they gave us f prime of 3. So all we have to do here is plug in negative 4. So it equals negative 1/4. And you're done, that's it. You just have to remember that the derivative of g prime of 2 would equal 1 over f prime of a. And they gave you f prime of a, so your answer was just the reciprocal. Okay, so you just have to remember that it's the reciprocal. All right, let's look at maybe a more difficult example. So this time it says, find g prime of negative 1/2 if g of x is the inverse of f of x, which equals x cubed divided by x squared plus 1. Okay, so we want to find the derivative of g without actually finding g, okay? Because trying to find the inverse of f would be very difficult, okay? So if you can remember the formula, you don't have to actually find g, okay? All right, so remember our formula is g prime of b equals 1 over f prime of a, okay? All right, so we're trying to find g prime of negative 1/2. Okay, we know that's going to equal 1 over f prime of a. Now, we know what f is, right? So we can easily find the derivative of f. That would just require a quotient rule. But we got to figure out what a is equal to, okay? Now remember, if g of b equals a, okay, remember that f of a equals b, okay? Or I'm just referring, back to that relationship. If f of a equals b, then g of b equals a, because these are inverses of each other, and they're going to switch your input and your output. Okay, so we know what b is. B is negative 1/2. So f of a would equal negative 1/2. So what we have to do to solve for a is we have to take our function x cubed over x squared plus 1. We have to set it equal to negative 1/2. And we have to solve it for x. Okay, because a is in place of x. Okay, so to me, this looks like a proportion. So I'm going to cross multiply in order to solve for x. But because I'm dealing with this negative 1/2, I need to either make like the numerator negative or the denominator negative. So I don't know. I think I'm just going to make the numerator negative. All right, so then we're going to cross multiply. This is just solving a proportion. So we're going to get 2 times x cubed, which is 2x cubed, equals negative 1 times x squared plus 1. All right, I'm going to distribute my negative. So I'll get negative x squared minus 1. And then I need to solve this for x. Now, how in the world am I going to do that? Well, to me, it's looking like a polynomial. So usually if we're trying to solve a polynomial equation, we'll move all the terms to one side, and we'll set it equal to 0. And then we could always try factoring, but I'm noticing I have 2x cubed plus x squared plus 1, so that's going to be kind of hard to factor. Let me just see if I can figure this out by inspection. What value of x would make the left side equal 0? Well, I'm noticing that this would have to equal negative 1, because then you'd have negative 1 plus 1, which would equal 0. So what value of x could I plug into 2x cubed plus x squared to get negative 1? Well, it looks like the answer is negative 1, because notice, if I plug in a negative 1, I'll get negative 1 cubed, which is negative 1, times 2, which is negative 2, plus negative 1 squared is positive 1, plus 1, negative 2, plus 1 plus 1 equals 0. So 0 equals 0. So in this case, x would have to equal negative 1. Okay? So on some of these problems, for some of them you'll be able just to solve for x algebraically, like factor, or just solve the equation for x. But if it looks difficult, then you could probably just figure it out by inspection. And usually in that case, it's going to be a fairly simple value, like 1, negative 1, 0, something like that. Okay, now, what did we just figure out? Well, we just figured out our a value, okay? We just figured out that f of negative 1 will equal negative 1/2. Okay, so now, go back to my formula. This is going to be 1 over f prime of negative 1, because we just figured out what a is. Okay, so it gets easier now. Now we have to find the derivative. Okay, so I think I'm going to work that out on another slide. Okay, x cubed over x squared plus 1. So remember, this is f of x. quotient rule. So low d high minus high d low all over low squared. Okay, and we're just going to simplify. And actually, you know what? Because I'm plugging in a -1, because I'm trying to find f prime of -1, I'm just going to go ahead and plug in -1 and not worry about simplifying. So I'm going to have -1 squared plus 1 times 3 times -1 squared minus -1 cubed times 2 times -1 all over -1 squared plus 1 squared. Now I know that looks ugly, but let's just break it down. Okay, -1 squared is 1, 1 plus 1 is 2. -1 squared is 1 times 3 is 3. Okay, minus -1 cubed is -1. And remember, this is 2 times -1. Maybe I'll use parentheses there. So 2 times -1 is -2. And then all over -1 squared is 1. 1 plus 1 is 2. And then 2 squared is 4. All right, it's getting a little bit easier. 2 times 3 is 6. Okay, minus -1 times -2 is 2 all over 4. So we end up with 4 over 4, which equals 1. Okay, so we just figured out that f prime of -1 equals 1. Okay, so we're going to go back to our original rule, and this is going to become 1 over 1, which equals 1. So g prime of -1/2 equals 1 in the end. So I know that seemed like a lot of work, and maybe my work is all over the place, but this was our main rule that we were using, okay? G prime of B equals 1 over f prime of A. So because we were given g prime of -1/2, because that would represent g of B, okay? So we had to figure out what A is. So in order to do that, we take the original function and we set it equal to B. So we took x cubed divided by x squared plus 1, set it equal to -1/2, and we solved for x. And we got x equals -1. And so then our rule became 1 over f prime of -1. And then we just had to find f prime of -1, which I did on the next slide. So we found our derivative using quotient rule, and then we plugged in -1 and simplified, and we got 1. And then we came back and we replaced f prime of -1 with 1, and then 1 divided by 1 equals 1. Okay, so that is how you find the derivative of an inverse function without actually finding the inverse function. Okay, so we'll definitely practice this some more in class. Thank you for watching. Have a good night.